Having a low contact resistance is desirable when making probing measurements. Increasing delta deflection on a tip puts more force on the tip, which will result in a lower contact resistance. More delta deflection causes the cantilever to bend more as well. The probe tip will scoot forward along the surface. We can use this to our advantage. Place the probe tip behind the contact with respect to the chosen head's position. By increasing the delta deflection, the probe tip will scoot into the side of the contact. Increasing the deflection further will cause the pressure between the tip and contact to increase, lowering the contact resistance. The picocurrent tab in Multiscan is used to monitor the contact at the surface. Running -1 to 1 volt ramps on the tips tells the user if the probes are on the correct contacts and how good the contact is. The more current the probe tip pulls, the better contact it has. By looking at only one node, we can tell if our other probe tips are on. Start with the drainer source, as the gate is not connected to an active region and will not show a diode ramp. The current draw will increase with probe tips on more nodes of the device. Monitor the maximum current the probe tip pulls. Place the probe tip and increase the deflection until the ramp looks stable. If adding more deflection does not increase the current, try working on a different probe tip. If too much deflection is added, the probe tip can scoot over the contact and the current will drop significantly. When this happens, decrease the deflection to pull the tip back over the contact. Replace the probe tip a bit further back and increase the deflection again to push the tip back into the contact. For good ohmic contact, we want all of our nodes on, with the diode ramps of the drain and source reaching their maximum current at the same voltage.